Okay.
NAP13. From here, main concept will start. Okay. This NAP13 mainly divided, we have divided this into two parts. Okay. Part one is all about concept and how to place the sprinkler, how to design everything. Second will be the hydraulic calculation, because I want hydraulic calculation at the end. I don't want hydraulic calculation in between. Okay. So if you see, this is an sprinkler. Okay, this is the deflector, and this is your frame. Okay, and this is a sill. This is a glass. So what is the liquid present inside? Anyone?
No idea.
Okay. So this
Size we know, 3 mm and 5 mm. The
Usable link
pressure.
like that, sir.
sorry.
Some liquid. Usable link or something like that. It will break, no?
Actually, yeah. I'll tell the sequence how it will operate and how it will break. First we are studying the outer body of the things. So this is a glass bulb. Okay, and inside that you have a glycerin. Okay,
Glycerin.
so it is a family from alcohol. Okay, I think you know
Silica
in
X.
12th, in 10 plus 2 you have learned all this, right? So
Yes.
whenever the measure properties of glycerin is, whenever temperature is set, for example, we'll set the temperature here for this, as it is red, we'll set 68 degrees Celsius. Okay, if if the temperature is going beyond 68 degrees, so what will happen? This glycerin will
Will
expand.
expand.
Once it expand, this glass will break and this seal will break. So water comes out. Okay, this is the sequence. I'll show you some animated video, you can understand. Okay. Next, by seeing this sprinkler, can you tell what type of sprinkler it is?
Upright sprinkler.
How you identify?
That deflector was.
Based on the
Deflector.
deflector. Okay. Yes. I'll show you. This is a upright sprinkler. Okay. By seeing this deflector, you can identify which type of sprinkler it is. Okay. Next one video I'll show you. In that, pendant sprinkler is used. So it will be flat. The uh, pendant sprinkler, this deflector will be flat.
SS will be there in between.
Yes. That we discuss. So as we know, NAPS standard is 13, IS code is 15105. Okay, so this is an overview of the sprinkler, and this color, okay, if you see here, it is red color. So red color is 68 degrees Celsius. Okay, orange, it is 57 degrees Celsius, yellow 79. So based on the operation, your things will change. For example, any industrial area. Okay. Any
And one
industrial
more thing,
area.
sir. This quick response and standard sprinkler, now where all we are using?
Sorry.
That difference any particular area? This quick response sprinklers was there, 3 mm bulb size, and standard was 5 mm bulb size. Is there any design criteria was there in
Yes,
this
it is
area
there.
we
It
have
is
to
there.
use
We'll
only
come.
quick
Yeah,
response?
we'll discuss that. We'll discuss next. We'll discuss. Okay. Where you will use, you can use one particular location. For example, one particular location, you can use both. There is no certain criteria for this. Okay. Here, this for quick response, the efficiency is quick. Okay. As the name is quick response, immediately it will act. Okay. After reaching 68 degree, okay, it will take less time to burst. Whereas the standard response, it will take little, some second more. Okay. Where there is a high hazard, there you will
Exactly,
use.
we can tell how many seconds it will take to burst.
Yes, we can. Okay. I'll tell next
Difference.
I'll tell RTI, one term is there, RTI, response time indicator. Okay, based on that you can measure. We'll discuss that next. So here you see different color is there, color code. So based on the color, based on the application, we will use it. For example, industrial area, you cannot use this red color. Okay, their temperature will be more. For example, any boiler, the temperature is almost 90-95 degrees. So in that case, you cannot use this 60. You have to go for 93 or 141. Similarly with kitchen, okay, where there is lot of heat is generated, you cannot put normal 68 degree. I'm not talking about residential kitchen. I'm talking about any commercial kitchen or any restaurant. So there you cannot put this 60 degree. You have to go with higher side, 93 or 104, 141, these two. So based on the application,
Sir,
you have to
kitchen,
choose which type of
sir,
sprinkler you'll use. Yes, yes.
for kitchen, sir, I have experience for the kitchen out system, separate system there is.
Yeah, yeah.
When they are preparing,
Where,
that is
which one you have put?
that is also one type of liquid
Hmm.
kitchen out system like that they are telling.
Yeah, that is altogether HVAC system. Kitchen node, they will give one sensor type whenever there is a more fire and all, automatically that they will have gas leak detected they will have.
Yeah, like that.
Hmm. I'm talking about sprinkler only. Have you used any other
Yeah.
sprinkler in the kitchen?
No, sir, I didn't check
General,
kitchen.
yeah,
Only
yeah.
small tea rooms like that they are using.
No, kitchen in the sense I'm not talking about residential kitchen. Residential kitchen is just a small one. You can use this one, not a problem. Okay, in
Yeah, easily. Yeah, that is easy.
commercial, yeah,
Yeah.
in commercial, these two I have used.
Okay.
This one and 1 2 kg extinguisher they are providing in residential building most of the time.
No, even residential, they'll provide extinguisher. They will provide a sidewall sprinkler.
Yeah, sidewall sprinkler. Yeah, sprinkler and 1 2 kg extinguisher.
2
That
kg
only I have seen most
APC
of
or
the time.
CO2 extinguisher. Yeah, what you saw in the slide, previous slide.
Yeah,
Okay.
yeah.
So we have different, before that, how it will operate, right? Let me show that. Then we'll go to the. So this is a pendant sprinkler. Okay. Here is a glycerin family of alcohol. Whenever temperature reaches 60 degrees Celsius, okay, this alcohol or glycerin will expand and it will break the glass and the seal breaks and water comes out from this. Okay, this is the sequence.
Yeah.
Today we're going to test it's a common fire sprinkler head. You've probably seen these in offices or buildings, warehouses, anywhere there's a fire protection system using these sprinklers. This particular one works when it gets to 155 degrees. There's a liquid in here that will expand in this glass ampule and break it and release this plug, which is called a pip, and it's a one-time deal. You can't reset them, and once that is open, it sprays water out. Not sure what the fluid in there is. It could be just like an alcohol, something that has a real low freezing point, so you don't break it if they're outdoors or exposed to cold weather. So let's see what it looks like in slow motion.
Clear?
Yeah.
Yes, clear.
Next is we have different characteristics of sprinkler. So we'll discuss that. First is your sprinkler thermal rating. As we discussed, different temperature will have different color code. Okay, you can see, right? The thermal rating of the sprinkler vary based on the sprinkler color code, as we discussed. Next is thermal sensitivity, which is your response time indicator, RTI. So for standard response, we have 100 seconds, means standard response whenever the sprinkler reaches the temperature 60 degrees. Okay, after 100 seconds, that means 1.5 minutes, it will start to operate. Okay, whereas quick response or easy separation fast response, it will take 75 seconds to operate. Okay. Here, next is sprinkler defined as the first response has a thermal element of RTI of 50. You have to mention in terms of RTI, okay, which is response time indicator. For this fast response, we have 50 RTI. For standard response, we have 80 RTI. Okay. Here.
So how we will find this one, sir?
Standard, you will not find. These things is, yeah, this is as per standard. You cannot find anything. Experiment. I have not done this experiment. This is already done by the manufacturer.
Okay,
That product catalog.
okay.
Right.
Okay, sir.
Next we have orifice size or K factor. We know, you know the formula, Q is equal to K root P. Q is equal to K root P. And some people they will tell K is 80. And some people they will tell K is equal to 5.6. So what is the difference between those two? Any idea? Okay, I'll tell you. So here you can see the formula K is equal to K root P, where Q is equal to flow. K is the orifice size, okay, coefficient, that is K, and P is the pressure, okay, what pressure it discharge. So if the units, all the units are in GPM, okay, if you maintain the flow in GPM, gallon per minute, okay, you have to find that the value is K factor is 5.8. If you maintain the flow in LPM, liters per minute, then it is 80. Okay. And similarly, if you maintain gallon, the pressure unit is PSI, and LPM, it is in bar. So anyone knows what is the conversion between all this? 1 gallon is how much? Is equal to 3.78 liter. Okay. We have US gallon. We are following mostly US gallon. Even we have UK gallon, that is 1 UK gallon equal to 4.2 liters. But we don't use this UK gallon. We mostly use US gallon. Next is 1 bar. How much PSI?
0.0689.
14.5 PSI.
No. Oh, 1 PSI is equal to 0.66089 something bars.
Yes.
Because we are converting PSI to bars, no?
Okay. So this conversion is clear. During our hydraulic calculation, we'll use this formula. Q is equal to K root P. Remember this. And another thing, just I want to tell you, yeah, in terms of height. Okay. Next point is terms of height.